So extraction of the iron, how we extract the iron, that we extract the iron in the blast furnace. And what is the ore of the iron? The ore of the iron is called hematite. Hematite is basically, it is iron oxide, Fe2O3, or iron 3 oxide, Fe2O3, but it also contain impurity which is sand. Sand means silicon oxide. So hematite, the ore is there. So ore of the iron is called hematite. Ore of aluminum is bauxite. Ore of the zinc is zinc sulfide, or also known as zinc blende. So first we have iron oxide or iron 3 oxide. We want to extract the iron or we want to remove the iron. Now, first what we do, how we carry out the reaction, it is the same way we extract zinc. That's the same furnace. But only difference at the last, because iron is having a high melting point, so it's not vaporized. Iron remain in a liquid state, whereas zinc is vaporized because the temperature of the furnace is more than the boiling point of a zinc. So first what we do, from the top we add a carbon, and again the same way from the bottom we blow the air which contain oxygen. So as a result, carbon from the top and oxygen from the bottom, carbon react with oxygen and it forms carbon dioxide. This reaction is exothermic because it's a combustion, and because of this reaction the heat energy is released, so the temperature of the furnace will increase. So first reaction, when carbon react with oxygen, it forms carbon dioxide. That's the first thing happen. Then the carbon dioxide which is produced in the first reaction, the carbon dioxide which is produced in the first reaction react with more carbon, because we are continuously adding a carbon from the top. So carbon dioxide further reacted with carbon to form carbon monoxide. This is the second reaction. What happened? The carbon monoxide is produced. How carbon monoxide is produced? Because the carbon dioxide reacted with more coke or carbon and limited supply of oxygen leads to conversion of carbon dioxide into carbon monoxide. And carbon monoxide is a reducing agent, because as we discussed in the last session, that carbon monoxide can reduce or remove the oxygen from different compound. So as a result, what happened? The third reaction is when the ore of the iron, which is iron oxide, iron 3 oxide, or also called hematite. So we add ore from the top now. So the moment we add ore, the iron oxide reacted with carbon monoxide, and as a result, it will produce iron metal and carbon dioxide. So equation must be balanced. So it is 2Fe plus 3CO2 is produced. So this iron which is produced here, this iron will not be vaporized because iron is having a high boiling point. So this iron will be in a molten state, and this iron will move towards the bottom of the furnace. So we'll get the iron at the bottom of this furnace. Then we want to remove this impurity silicon 4 oxide, or which is also called a sand. To remove this impurity, what we do, we add calcium carbonate again from the top. So when we add calcium carbonate from the top, due to the heat energy, the calcium carbonate CaCO3, it undergo a thermal decomposition and break down into calcium oxide plus carbon dioxide. So this calcium oxide, it's a basic oxide. Calcium oxide is a basic oxide. So this calcium oxide react with the sand which is already present with the ore, because ore contain a sand as well. So this calcium oxide react with silicon oxide or sand. So as a result, when calcium oxide, which is a basic oxide, reacted with silicon oxide, non-metal oxide, which is an acidic oxide, it will form a compound calcium silicate CaSiO3, which is called slag. So slag will form at the top, And iron and slag does not mix with each other. Why? Because they have a greater difference in the density. So when two liquids, they have a greater difference in the density, they are immiscible, they don't mix with each other. So at the bottom we'll have iron, and at the top we will have a slag. So first carbon react with oxygen, give carbon dioxide. Carbon dioxide react with more carbon to produce carbon monoxide. Carbon monoxide is a good reducing agent. It removes the oxygen from iron. And then we add limestone, which is calcium carbonate, decomposed to give carbon dioxide and calcium oxide. And this calcium oxide reacted with the sand, silicon 4 oxide, to form a slag. This is what happened in extraction of iron. Is it clear, the concept of how iron is extracted in the blast furnace? But the iron here which we extract in the blast furnace, it's not a pure iron. Because what happened with this iron, as we are adding a carbon, so some of the carbon also mix with iron. Because as we are continuously adding a carbon coke, so some of the coke does not react, and that coke mixed with a carbon, that coke or a carbon mixed with the iron. So this iron which is extracted in the blast furnace, it's not a pure iron. So what we do, so the iron which is there from the blast furnace is not pure. That is known as pig iron. And this iron which is not a pure, because it contain some carbon and sand as well, because not all of the sand is removed. So the iron which is we extract from the blast furnace, that is not the pure iron, that is known as the pig iron. Now this pig iron, what we can do, if we remove all of the carbon, so there is a pig iron, and from this pig iron, if we remove all carbon from this pig iron, what we call that as a wrought iron. But if we have a pig iron and we just mold into shape, like we make certain shape, we call that as a cast iron. And if we, in the pig iron, if we increase or decrease the amount of carbon, if we increase or decrease the amount of the carbon, what will happen? It will be known as steel, or it becomes steel. And steel, when we have a steel, if we add other element such as nickel and chromium, then it will become stainless steel or alloy steel. So the iron which we extract from the blast furnace, it's not a pure iron, that is known as the pig iron. And this pig iron, if we remove all of the carbon, like there is no carbon, we remove all. So then it become a wrought iron. And wrought iron, because when wrought iron is a pure iron and pure metals are highly malleable, so if it's a wrought iron, it will be malleable. Malleable means we can hammer into shape. So we can use to make doors, we can use to make chains. Same thing, if the iron which is extracted from the blast furnace, we just make a certain shape, we did not change the composition, we called as a cast iron, and cast iron are usually hard and hard and rigid because they contain carbon, that's why it is hard and rigid. And what is the use of the cast iron? Cast iron are used for engines. The car engines, they are mainly made up of cast iron. Even for grill pans, you will find the grill pans also they are made up of cast iron. They're very hard and dense, like, and rigid also, they don't change the shape easily. Then if we can increase or decrease the amount of the carbon, like example, if we increase the amount of the carbon, then it will become a hard steel. And what is the use of the hard steel? Hard steel is also, if we increase the amount of carbon, it become a hard steel. Hard steel is also rigid and it can be used. Rigid means it does not change its shape easily. So it can be used for drills. The drill machines, the bed of the drill machine, you will find it is made up of high carbon steel. High steel, or you can also say high carbon steel. Normally, high carbon steel is a common term which is used. But if we decrease the amount of the carbon, if we decrease the amount of the carbon, then it is known as a low carbon steel, and low carbon steel are usually soft. As a low carbon steels are usually soft, so they can be used for car bodies. The car bodies, when you will find see the car bodies, usually when in case of a collision or it hit any object, the body can easily deform because it is made up of low carbon steel, which are usually soft. Soft does not means when you touch it is soft. Soft means it can change its shape easily. And if we add other elements such as nickel and chromium, we remove carbon here. Basically here, first what we do, we remove carbon and we add other elements such as nickel and chromium, so it becomes alloy steel. Or stainless steel is one example. What is the benefit of alloy steel? They cannot rust or it resists corrosion. So as it does not rust or resist corrosion, so we can use for cutlery such as knife, fork, or we can also use in chemical plants. So spoon, knife, they all are made up of stainless steel or chemical plants because it does not rust. So they are also made up of stainless steel. So this is how the carb basically the iron from the blast furnace divided into different proportion depending on what we want to make. Like if I want to make car body, then what we do, the iron which we extract from the blast furnace, we remove the percentage of the carbon, decrease the percentage of the carbon, and it will form a low carbon steel which can be used for car bodies. If I want to make car engines, then what we do, the cast iron, the low carb, the pig iron, just mold into shape, it will become cast iron and we can use for making engine blocks. or we can just remove all of the carbon, so it will turn out to be a wrought iron. Is it clear? This flow chart for the properties and the types of iron and steel. Then converting the iron into steel, how we can convert, like example, if we want to convert the iron into steel, so that is called a basic oxygen furnace. So in a basic oxygen furnace, we can convert the iron into steel. This iron which we extract from the blast furnace. So this iron, the molten iron which we have in the beginning, this is afterwards, but in the beginning, this is the iron which we extract from the blast furnace, which is called a pig iron. So what we do, why it is called a basic oxygen furnace? Because we use basic substance here, or a basic oxide, which is calcium oxide. And oxygen is also used here, that's why we call oxygen. And furnace is when we heat something in a closed vessel, we call that as a furnace. So the pig iron contain what? The pig iron contain impurities such as carbon. For example, these dots, red dots are representing carbon. And it also contains some of the sand as well, which is silicon oxide. Some of the sand is also there. We want to remove, using a basic oxygen furnace, we can decrease the percentage of the carbon. If we want to increase, we can just directly add carbon, but if we want to decrease, we use a basic oxygen furnace. So a hot oxygen, a pure oxygen is blown through this. So when we blow the oxygen, pig iron contain two elements. It contain iron, it contain carbon. But because carbon is more reactive than iron, so this oxygen will react with the carbon, and carbon react with oxygen, it gives carbon dioxide. And the carbon dioxide gas will escape from the furnace. Then how to remove this sand? How this sand is removed, like silicon 4 oxide? So for that, we again add calcium oxide. So when we add calcium oxide which we add again reacted with silicon 4 oxide or sand, and it will again form calcium silicate or slag. So slag will be there at the top of iron. So first we remove the carbon by blowing oxygen through it, and then we add a metal oxide or a basic oxide, which is calcium oxide, react with the acidic oxide silicon 4 oxide to form a slag. And slag can be siphoned out or tap out from the furnace. Is it clear that how we can change iron to steel or pig iron to steel, by or how a percentage of the carbon can be reduced from the pig iron? So you can see a furnace here. This is called a blast furnace. The things which we add from the top, we add carbon. So first carbon, when we add from the top, reacted with, here at X we add air, but air mainly because contain like oxygen in the air reacted with a carbon. So carbon plus oxygen give carbon dioxide. And then carbon dioxide reacted with more carbon we are adding from the top, produce carbon monoxide. Then this carbon monoxide reacted with ore of the iron produce iron. So iron will be settled at the bottom. But because we are continuously adding the carbon, so this carbon, some of the carbon does not react and it mixes with iron, and the calcium carbonate decomposed to produce calcium oxide and silicon 4 oxide uh, reacted with calcium oxide, because the calcium carbonate produce calcium oxide and carbon dioxide, and that calcium oxide react with silicon 4 oxide to form a slag on the top surface. Now the question is, the following reactions are shown in which happen in the furnace. Which reaction is used to increase the temperature Basically, which reaction is exothermic? So the first reaction in which the carbon was reacting with oxygen, carbon plus oxygen give carbon dioxide, that is the most exothermic reaction. So A should be the answer. Which reaction is example of thermal decomposition? The term thermal decomposition means we will have one reactant and we will have more product. So when we have more product and one reactant, we call that reaction as thermal decomposition. So only reaction which is having one reactant and more product, that is B. So that's why B is the right answer. In which reaction carbon both oxidize and reduce? So oxidize and reduce means addition of oxygen or removal of oxygen, both happen. So when we check, if you check equation D, there is a carbon dioxide reacted with carbon to become carbon monoxide. So here carbon dioxide become carbon monoxide. So this is reduction. And carbon becomes carbon monoxide. So this is oxidation. So in which reaction both oxidation and reduction happen? That is in D. Then which equation shows a removal of impurity from the ore? The impurity from the iron ore or from the iron, the impurity which is present in the iron, that is the silicon 4 oxide or sand. So which reaction shows that sand is removed? So sand is silicon 4 oxide, it reacts with calcium oxide to form a slag. So C is the right answer. And which equation show that acidic substance react with a basic substance? So metal oxide is a basic, silicon oxide is non-metal oxide is acidic. So calcium oxide is a basic substance, silicon oxide is acidic. So that's why again C is the right answer. Then use the diagram of the blast furnace to help your answer to these questions. Which substance entered the blast furnace at X? So normally what we do, we add a hot air from the bottom and which substance leaves. So hot air is added from the bottom, carbon is added from the top. They react, then iron is there at the bottom. So we have a impure iron or we'll have a pig iron at the, which we take out from the furnace. So which substance leave? So impure iron, or we can also say iron leave the substance at Y. Name the two waste gases that leave the furnace. So which gases will leave the furnace? Because carbon dioxide gas is produced, CO2 is there, and carbon monoxide is also produced. So these gases will leave the furnace. Then the graph shows how the malleability of the iron changes with the percentage of a carbon. As you can see, if we increase the percentage of the carbon, it becomes less malleable. Less malleable means it becomes rigid, that it does not change the shape. So less malleable means it does not change its shape. So describe how the malleability of the iron changes as the percentage of the carbon changes. So if percentage of the carbon increase, the malleability will decrease. So if the percentage of carbon increase, the malleability will decrease. It will become less malleable. And then explain the iron obtained in the blast furnace contain high level of carbon, like more carbon is there in it. How the amount of carbon in iron can be decreased. So how we can convert, basically how we can reduce the carbon or remove the carbon. So what we can do, like this is related to basic oxygen furnace. So we can blow the hot oxygen and that oxygen react with the carbon to form carbon dioxide. So we blow the hot oxygen through the mixture which contain, because the iron which we extract from the blast furnace is not a pure iron, it contains carbon as an impurity. So blow the oxygen through it, oxygen react with the carbon to give carbon dioxide. So this is the question related to extraction of iron. Then the last part of this is the uses of the metal. This is the last part. This is just you have to learn the uses of the metal. You don't have the property and the uses. Like aluminium does not rust, so we can use for food container. It has low density for container or packaging building. Low density, strong and conduct electricity, so we can use for wiring, long distance wiring or high tension wire. Low density, strong and cheap for transport vehicle. Low density and conduct heat we can use for car engine. And even aircraft body, not car engine, this is about the aircraft body. When it is having a low density and strong, then zinc is there. It can be used in cell, or it can be used for galvanizing iron, protecting the iron from rusting. Same thing, iron for reinforcement it can be used, and the copper is there, can be used for wiring. These are some uses of these elements. Now rusting of the iron, as we know, what is the concept of the rusting? If we have a piece of iron, with the passage of the time, that piece of iron develop an oxide layer, and we call this as a rust. And what is the effect of this rust? It reduces the strength of the iron, it become weaker. So whenever rusting of iron occur, both oxygen and water are needed for rusting. Without them, iron will not rust. Like example, if we have one test tube which is dry air means there is no water. Another one is a boiled water. So boiled water means no oxygen. Another one is air and water, both are present, unboiled water. So which one will rust? The first one will not rust. Why? Because there is no oxygen. The second one will not rust. Sorry, the first one will not rust because there is no water. The second one will not rust because there is no oxygen. The third one will rust because there is oxygen and water, both are present. So whenever iron react with oxygen and water, it will form hydrated iron 3 oxide, which is also known as rust, and it is brown in color. How we can prevent the iron from rusting? If we want to protect the iron from rusting, we can paint it. Normally you have seen, like example, doors are there, or structure which are made up of iron, they use to paint them so that it won't rust. We can also grease, put a layer of oil or a grease so that it won't rust. We can cover with a plastic so it does not allow oxygen to interact with iron, so it won't rust. And we can use a more reactive metal or coat with a metal, like example zinc. So if we coat with zinc, that we called as a galvanizing. So zinc is more reactive, it will protect the iron from rusting, so iron will not rust. Or we can also electroplate with a less reactive metal. But in electroplating, once the layer is removed, the iron will start to rust. So these are some techniques which can be used to prevent iron from rusting. So the topic 10, which was about the metal, the reactivity of the metal, properties of the metal, and extraction of the metal, is done. Any question related to the class today?